so far, the entire lectures that we have had so far, all the problems that we took had a very top-down structure. We started with the problem definition, and then we tried to find a way that would work for all the possible cases, right?
Right.
So, and then slowly we developed it. Step by step we developed the algorithm, and then regardless of what data we give it, the algorithm should work. That was how it was constructed.
Yeah, so we will have a uniform algorithm.
We'll have one algorithm or one method,
which is basically based on some problem analysis that we do.
Analysis of the problem.
And this will always work for all the
data. And you make an algorithm. It will be an algorithm, fixed structure of
some
way
steps,
of doing things, steps. And very fixed, right? Rigid way in some sense. There is a flow chart or a pseudo code or something which is written down, and then you're not allowed to change it, right?
Correct.
And then as the data comes, program keeps executing on the data and gives you a result. And you might rewrite the program and create another program, but the program itself is not changing simply because it saw a new data item.
Correct.
Right? Program is not changing. That's not how real life works, no?
Yeah, that's true. I mean, sometimes when we make decisions, right, so we look at various things and we decide to do one thing or another thing. For instance, we might be waiting at a bus stop, right, and we might want to decide whether to give up and catch the next bus. I mean, maybe the next bus is not going all the way, but we might have to change buses somewhere. Is that better, or wait for our actual bus? So,
or take an auto or something.
Yeah, so some such things. So we can't, I mean, what works today may not work tomorrow, or over a period of time the bus frequency may change.
Correct.
So we might have to change our strategy.
And if you generally ask somebody, is the bus likely to come? The guy, he'll say, I don't know. First time I'm also here for the bus. Or he may say, no, he's a veteran.
Yeah, or somebody,
every day.
The tea shop guy might say that bus just went. Maybe it came early today. So then it's not going to come.
Or after 1 month, if you keep standing every day and getting to the bus after 1 month, you'll figure out.
Yeah, correct.
You learn.
So you actually learn learn a strategy by watching.
You learn by watching, experiencing. But we are not doing all that, right? We are not learning.
So far we are not doing anything like that, right?
So this would be learning, experiencing would be some kind of a bottom up.
Yeah, so you, instead of taking a strategy and applying it to all the data, you are taking the data and deriving a strategy from it, right? So incrementally.
As the data comes.
As you see more and more data, you adapt your strategy to make it. But of course, this strategy is not going to be 100%. That is the nature of the, the nature of the problem is also like that, right?
It depends on the problem, I suppose.
Because
not all problems.
We'll have this
kind of thing is good for. So if the problem is very structured, very well defined, then top down might work.
Yeah.
The problem is a little bit fuzzy.
Yeah. Then you have to make a call on.
And it may also sometimes things may work in for one set of data, may not work for another set of data, but you're okay with it. Because this is a set of data you're likely to encounter anyway.
Correct.
Isn't it?
Correct. Yeah.
So suppose I say that this thing is not going to work for a very large number of students in the class. It will work only if there are only 60 students in the class. I'm quite okay with that. I have only 60 students in my class. Right? I don't want it to work for 6,000 students and 600,000 students and all. Isn't it?
Yeah.
So sometimes if it works for my class, and my class is going to be constant for the whole year. If I figure out it works for my class, it works for my class. At least I can use it for this year. Next year maybe I have to try something else. We'll see next year. Right? So this bottom up seems to be a new method, but
so how does one go about it?
One can take some example problem. Now I was thinking this, if you take this classroom data set, right? While looking through it, when we're doing all these problems we are working through, it looked like from the marks or something, you can make out who the student is. Suppose I don't tell you who the student is. I don't say there's a reader. I just tell you the total is 173, physics marks is 42, let's say, or something. Basic mark 53. From these two, can you identify the student?
Okay, so you want to identify the student from some information which is given on the card, but not the name.
No.
Okay.
It's like when face recognition, they just look at the nose and figure it out. Something like that, right?
Correct.
So or fingerprint. You can identify. Almost exactly.
Yes.
So that works.
And they measure all these distances and then they figure
something
out.
They do.
So there are some numbers which come and then they figure out from that who it is.
Who it is.
So in this way we have some numbers and we want to know if the numbers determine the student.
Yeah.
Rather than the other way around.
The other way around.
Right? So we know which student has got the marks, but can we guess the name of the student from the marks?
Marks.
That's what we want.
So let's start with something. Let us say we have the total.
Okay. So we want to say that if we
If
know
that's
the
the
total,
total.
we know the student.
Is that correct? Or
Yeah.
how do you know that?
So,
So we can take, so randomly I'll pick one card,
okay.
210,
Hmm.
right?
Yeah.
Now we have to check, there may be other students with 210, we don't know.
Yeah.
For now, I can note down,
Yeah. So we can
210
say,
is Arshad.
yeah. So should we note it down?
We can note it down,
maybe.
210 is Arshad.
Okay.
We can say like this. And I randomly take another card. As long as this works, it's fine, no?
Yeah.
Take another card, randomly.
Okay. So 196.
Battery veil is 196. So far, no clash.
Okay.
So from total, I am able to guess the student. It seems.
Seems.
2 examples.
Okay.
Okay. Third one, Monica, 221.
Okay.
So if you tell me
So far-
221, I'll say it's Monica.
Okay. So far it's looking good. So if you give me a number and if I know this table, then I can look up the table and say, okay, if it's 221, it's Monica.
Monica.
Right?
Yeah.
Now, of course, how many things do I need before I can agree on this? So shall we try this now? So supposing can we conclude? So there are about 30 students in this
Yeah.
class. So we picked up some 3 random ones and they turned out to have different totals.
Correct.
So is this a good enough sample for us to
I don't know. I have no idea. Maybe we should try a few more. Let's try a couple
Yeah,
more.
okay.
Let's see one more random one. 224. Okay. It's close but different. This is Gautami.
Okay.
Should I try more? Samir, 250.
Okay.
So far seems to be working. Now, of course, one can say we have got 6. So 6 out of 30 is quite a big sample size.
5 out of 30. Yeah. 5. Yeah. So
5.
1. Yeah.
1 by 6.
1 by 6. Yeah.
It's good. Normally in statistics it should be all right, no?
Yeah. So more than 15%.
So this works? How do you say?
Well, we'll have one way to do it is just to check, I suppose, whether there are any students, but which we can do in a small enough set. We can check whether there are actually 2 students with the same total.
Yeah. You can try it.
Now,
Let's
yeah,
see whether.
in general, this may be hard to do if we don't have all the
So if
information.
it is sorted,
Yeah. So let's.
I've sorted it.
Okay.
So we just have to check it sorted. You have to just go and see whether there are neighboring cards the same
Yeah.
number, right?
Correct.
181, 187. We have taken out some. Okay,
Yeah.
but doesn't matter. You have it there.
Yeah.
188, 189. Oh, close.
196 is here.
198. 204. So far, so good. 209.
210 is here. Ah. So we have
So
210 already.
Bhunesh. So by 210 you cannot say.
Yeah, because 210 we have Arshad already we found, and now we have.
Bhunesh. So then what do we do?
Okay, so we say,
So you have 2 guys with 210.
so it's like a tie, right? So you have
Arshad.
tiebreaker.
Arshad, okay, tiebreaker. Arshad and Bhunesh. So Arshad and Bhunesh. So what do we do now?
So let's see, and there are other things on this card. So of course we have other marks, but we already have the total. So maybe we should look at something which is not marks. So we can say maybe,
Month of birth.
yeah, which month they are born.
Date of birth will obvious because everybody will have different date.
Yeah.
Actually, there are 2 guys with same, but
Yeah. So
you
let's
take
say,
month of birth.
yeah. So
We want to use minimum information. We can take city.
yeah.
In
So
this
let's
case,
take.
there's different city.
Yeah.
We can take month of birth, or we can take 1 mark also. We can take say physics marks. That also is okay.
Okay. So which one should we do?
Let's start with month birth. Month of birth.
Okay.
So,
So now we are saying that if they are equal on total, then we will check that they are not equal on month of birth.
yeah,
So they should be different on
month of birth.
month of birth. Okay. So we saw one duplicate, which is 210. So if we continue, let's see if there are more duplicates and see whether this works. So this, so now we are saying plus.
So, so we are told in case of Arshad, so we will be given basically 2 things. In case of Arshad, we will say December
Yeah.
210 will say.
Yeah. Correct. So I'll just write it on top of it. December, and I think Bhuvanesh was November. Right?
This was November.
Yeah.
Okay. And 216? No, no.
No.
219, 224,
Ah,
224
yeah,
also.
224 is there.
Okay. Clarence and Gautami. All right. Now this is September and this is December, so it does discriminate.
Yeah. But already in those 5 that we got,
Huh.
We had already got 2 cases where they were not unique. This is quite surprising. September and December. Okay. But at least with the month it works.
With the month it seems to work, at least so far it works.
224. Okay.
227.
227 we don't have.
And here it says there are 227s.
Okay.
Okay. JK and Gopi.
But May and July. Okay. So that works. So should I write it down?
Yeah.
So we have 227, JK, Gopi, we have May and July. So far this rule is working.
We will make it harder. I think I don't want to give them exact marks. I don't want to give exact marks. 240.
Okay. 240 is also
240. 2 people, Nisha and Ritika. September and November. So again month seems to work.
okay.
So 244, 247, 252, 252. March and September.
Okay. So this is another duplicate. Aditya and Kalyan. Okay.
Then it's 254, 261, 276, 280. I think these are all different.
Yeah.
Now,
So,
I mean, let's say for a moment I don't give you the exact
Yeah.
marks, because exact marks basically already has too much information, you know.
yeah,
I give you only the grade,
correct. Let's say you get only the grade.
A, B, C, D.
Okay.
So then the value of total, ability for the total to discriminate goes down like anything.
Correct. So what if I use grade?
I have only the grade.
Okay. Grade as a total grade.
Total
Okay.
grade.
Okay.
And I have month,
Okay.
and let's say I have town. Good? Will that work?
Okay. So these 3, are they enough? Right?
Ah.
So we can try.
So let me put this back so we can write the grades for the students. So we have to decide the grade first. So what grades do we give? We had given it earlier, I think, but we can do it again. We have divide the range into range.
Okay. So you want to divide into quarters.
Quarters, yeah. So we are going from 173
Okay.
to 281, 173 to 281.
Okay. So that's 108, 50,
108 divided by 4,
so 27.
27.
So you want to do it according to equal mark boundaries.
Equal mark boundaries.
Okay. So we'll have say like 210 and 237. No, is that right? Doesn't make sense. Something is wrong. There will be 237 and then
This is D, this is C, this is B, and that is A. So 2
yeah. So after 27, so I'll have 264. So
No, 173, 281 is
yeah.
100 and
This will be 200. Sorry.
54, 27.
This will be 200, 227.
200, 227, 254.
Yeah, so let's write it down properly. So the grades now are 173, 200, 227, 254 and 281. So, so everything below 200 will be a D.
D grade.
Everything below 226 and above 200 will be a C
C
grade.
grade, yeah.
And this will be a B grade, and everything in this uppermost thing will be a
A grade.
A grade. Okay.
Mm.
So now,
So I'm only told the grade.
yes, I'm told the grade, which is in these.
Which means that these guys, all these people from 173 up to 200
will have the same.
will have the same grade. So you can't discriminate all of these now.
Okay, on the grade. Okay. So now I will ask you, give you the grade and then give you the month of birth.
Now I can tell you the month of birth.
Okay. So now maybe we can just see in this thing how they divide up according to month. So we have May.
You make a table now in this.
Okay. So we have
So your first thing is you started with
yeah
grade.
grade yeah. So we start with the grade. So let's
You could make this is like a decision tree you're making. What do you
yeah
mean?
yeah. So we can take the grade.
So,
right?
first check the grade.
And then in the grade can fall into these four
buckets.
Four categories, right? So
first you're saying check the grade.
Yeah. So the four categories are D, C, B, and A.
A. Okay.
So now we are going to check for each of these. We are going to check the month.
We want to check the month. Again, month can be 12.
Yeah, but we'll see because we'll only record the ones that we have. But there could be, in principle, 12 different.
12 possible branches could be there.
Yeah.
So this is May, Rida.
Okay.
Now if another person falls in May, that means this is not enough.
Yeah.
Right?
Yeah.
You can put there the leaf as Rida.
So should I just, okay, so I'll write Rida. Okay.
This one is December.
Okay. So I won't write it in order, I'll just write it as it comes.
Siddharth. Then July.
Okay.
It's Priya. Then Srinidhi is Jan.
Okay.
So far so good, huh?
So far they are all different, yeah.
Jan. Another Jan.
Okay.
Okay.
So already
we are colliding here. Huh? So Shashank. So the two.
Who are in January.
So in January I have to discriminate between these two.
So we said that we would go by town.
Town is also Chennai.
So now we are in trouble. So this is not going to work. So if I say now town.
Again they will come to the same bucket.
Yeah. So now I say town. They are both in Chennai. So these three, grade, month and town, city,
are not enough.
Are actually not enough.
But I have the gender. They are different in gender. This is male, this is female.
Yeah. So you could have done gender. So how do we find this out, right? So we want some three things.
Yeah, that's the question I think. Yeah, that's the key question that you're asking.
Or instead we are saying ask gender.
Ask gender.
Because that happened to work for these two. But now we may find that you go to some other category grade.
This is how learning works. You try it, no?
Yeah.
Then keep changing.
Okay. So now we do gender.
Let's do gender. Yeah.
Okay. So let's do gender.
Now again, the question is whether you should start with grade first or you could have started with something else first. Grade, maybe you should have started month first because month is dividing more to 12.
Month is dividing into 12. Gender is only dividing into 2, so it's not going to be
not a good idea, no?
Good idea.
Start with month first and then do grade.
Okay. So we start with month first. Okay.
No?
You can try that. Yeah. So then we'll have these 12 different things. So
we'll go one by one again.
Okay.
Ideally, one should take a sample and do. How do we do this? Actually, typically you will take one small subset and you will do it. See whether it works.
Yeah.
So it works for a subset.
So maybe let's take 1/3 of them, 10 of them, say. Right? So
not
just
in
take
order, right?
Just take every third one, maybe something like that.
Okay. Let's take third one. I want to keep it in order. It's easier for us. Okay. This should be random enough. No?
Yeah. Hopefully.
Okay.
So maybe I'll just rotate these. Yeah. Okay. So we should get 10 cards out of this to work with.
And if it works for 10, we are saying that it might work for all. We don't know. Huh?
Yeah. That's a big.
Because the months are 12.
Yeah, we will only see 10 months.
Maybe you shouldn't take months as 12. Let's take Jan to March. 4 only make it.
Okay. So first
Quarters.
Quarters. Okay. So we have now Jan to March. Then we have April to June. We have July to September. Then finally we'll have October to December.
So that makes it 4. I think that's fairer.
Okay. So like grades are 4, these are also 4.
Yeah.
Okay.
Now let's see what happens. Right? We have taken 10 random.
Yeah.
So right, assume to be random. So this is July.
So Priya comes here.
Priya goes there. Then this is February.
So Surya goes in the first one.
Okay. Then January. So Kavya also.
Kavya is
there.
also
So
there.
clash.
Okay.
Clash. So we'll discriminate later.
We'll discriminate later. We'll put them all down.
Bhuvanesh is November.
Okay.
Monica is March.
So she's also on the
Clash.
first row.
Okay. JK is July.
Another clash.
Okay. Ritika is November.
Another clash.
Samir is March. Not coming. The others, April to June is not getting anybody. Geeta is May. Okay, fine. You got one.
Okay.
And Rahul is April.
Okay.
Okay.
So now we got our 10.
We got 10.
So now we want
to look at grade.
grade.
Then we'll look at gender.
Okay.
Right?
Yeah.
So what you want to do now? You will see whether Surya, Kavya, Monica and Samir.
Yeah.
So we'll check them out. Surya, Kavya, Monica and
Samir.
Samir.
Yeah.
So these are the 4. Okay. Now we want to see whether these 4 can be
Separated on grade.
separated on grade.
Okay.
So,
So if it is Surya is 189 is a D.
okay.
Okay. Okay.
Kavya is 204.
That's C.
Right. So far so good. Huh. Very nice. Huh. Monica is 221.
Also C.
Gone. Huh?
Okay.
And they also happen to be the same gender.
Yeah. And Samir is 250, which is a B.
So gender doesn't work. If you take months as, if you don't take distinguish it by month,
Yeah.
but Kavya and Monica, if you're taken actually the month, then January and March it would have separated out.
Yeah.
Maybe now you can take month after this, after you do it in quarter.
Well, month you're done. No, we want to take town. Town or month? Because
Town you can take, yeah. Town you can take, Chennai and Bangalore.
Okay, so here town works, but not gender. Right? So earlier gender was
Gender worked, yeah.
good for that, but here town is
Sound
good.
better.
Okay.
So anyway, this tree says basically check whether or not they are in Jan to March, April
Yeah.
to June, July to September, October to December.
Yeah. And now here,
Then it says take the grade, then it take the town. Huh?
yeah. So here gender is the same for both Kavya and Monica. So instead we would take town. But then can you do that? Can you sometimes ask different questions?
Depends on what path you take, no?
Right? So if they are born in January, then we will ask grade and town.
Ah.
If they are born in July, we might ask
Something else.
Something else.
Why not? It's a tree.
Yeah.
You know where you come from, right?
Yeah. Yeah. Okay.
All right.
Why not?
So here I put town here and
So
see
I'll put
we have
town.
separated them out.
So I will cancel that out, write down. And then I'll get Bangalore and
Okay.
so Bangalore and Kavya is Chennai, right?
So this worked so far for this set.
Yeah.
Let's try the others. Okay.
So now we have to look at Geeta and Rahul. Maybe they already have different grades because Rahul was our topper, I think. So let's see where did
Yeah,
Geeta-
I'm sure. Yeah, Rahul was our topper. Geeta and Rahul, no?
Yeah.
254 and
But they
281.
both got A's.
Okay. So grade didn't work for them.
Yeah. So again we have to ask one more question. But again we
Town.
can do this
Town you can do.
So both are here. But then if we do town as then we'll split Geeta and Rahul by town. So what didn't work for Srinidhi and Shashank seems to work for others, town.
Then any other clash? Yeah, we have
Priya
Priya
and JK.
Priya and JK. All right. Priya and JK.
So yeah, they have different grades. So
They have
here
different
we-
grades.
yeah, so 187. So Priya has a D. So if I go by grade, so Priya has a D and JK has a B. So that's not a problem. We already separated them. Then
Okay.
finally, we have Bhuvanesh and Ritika.
Bhuvanesh and Ritika.
And again, I think they have different grades
Grades,
because B and C, I think. Right. So what was, maybe I got Priya's grade wrong. Just check Priya's grade, 181. No, it should be D. Yeah, right. D and B, correct. And here it is C and B, right? So this is Bhuvanesh and this is Ritika. Okay. So in two cases we were able to actually do it with two questions. And in
so what we are saying that if you see January to March, date of birth lying January to March, and grade is D, then the person is Surya, identified. We don't know, we'll see, we have to see other cards. This is from the sample.
Yes.
If the date of birth January to March and the grade is C,
then it's Kavya.
And if the town
is Bangalore,
Bangalore,
then it is Kavya.
Then it's Kavya. If it is C, then it's Monica. This is how we have got so far. Let us just take a couple of more cards from this set and see whether this formula, this algorithm works. It's an algorithm, right?
Yeah.
You created some, learned some algorithm, huh?
Yeah.
Without doing anything, huh?
Yeah, correct.
Earlier we had to do something. Here, somehow we learnt it, huh? This is nice actually. This is better. I like this. So
let's see how it works.
Let's see how it works. Now we take this Rida. It follows the algorithm.
Yeah.
So May, where are we?
So we are in this one.
Okay. Then we are supposed to look at grade.
Yeah. We have never seen that
173.
grade. We have only seen an A grade.
So we can
put new grade. Right. So if the grade is D, then it is Rida. Okay.
So this works for Rida, no clash. Let me just take another random one from somewhere. Okay. Tausif.
Okay.
216.
December. Okay.
Born in December. 216 is?
Grade is a C, so same as Bhuvanesh.
So we are supposed to use by the rule. We don't. There's no rule for this.
There's
yet.
no rule yet, so we have to decide.
We'll have to use the same what we have seen so far.
Town. Let's see town. So town is Trichy. So we have to go back and see what was Bhuvanesh's town.
Bhuvanesh is E-Road.
Thankfully.
Okay.
So town, if we ask here, then if we go to E-Road versus Trichy, then we have separated out these two. Okay, not bad. Okay.
Okay, let's take one more random. Arshad.
Okay.
December, so here. Okay, 210.
210 is C.
Clashed.
Yeah.
Chennai, but luckily.
New city.
Okay.
So now we have Chennai. Okay. So far so good. So we have these three questions which seem to work.
Try a couple more, huh? Yes, that's for the heck of it. Nisha, September.
Okay. So September. Grade is
A.
B.
B.
Okay, same as JK. So now we have to figure out
JKs. JK, Chennai.
Okay, so here JK and Nisha are separated by Chennai and Madurai. So again we have survived.
Last one. Huh?
Yes.
I think town again has too many possibilities.
If we had had state, maybe it would be.
If you had said state, then all this E-Road,
Okay.
Trichy and Chennai and all will collide.
So August,
August,
D, Priya.
Priya.
Victory Vale is here.
Priya is Nagarkoil.
Okay. So again we survive.
Because we have town as a huge discriminator. It's
Exactly,
doing a lot of
yeah.
things. It's got too much information. But this shows something. This is demonstrating something to us, right? What is it saying? It's saying basically that we can look at some examples.
And then build up this kind of a decision tree, which is like an if then else in our notation of pseudocode. So we can come up with some rules in the form of if it is this, then it is this and this, then it's something.
Yeah.
Otherwise, if it is this and this and this, some other combination, it is this thing, and so on.
Go on like that.
Yeah.
Try it for a few samples. If it's working for those samples, make it
Yeah.
work for those samples. Then keep adding one element at a time.
Yes.
If it works for a sufficient number of such examples, you just take it as a working thing. Of course, it may be wrong because it may wrongly identify somebody.
Yes.
Even this, when they go through the full thing,
Yeah, there may be clashes which don't get resolved with these 3 questions.
Right.
This is quite possible. Yes.
so in that case, it's basically identifying the person wrongly.
Hmm.
Maybe wrongly identifying or something it's doing,
Yeah.
right? You may, if to, for example, here when we had Kavya and Monica, when we reach Monica, we may say it's Kavya actually, but it may turn out to be Monica.
Yeah.
So you may wrongly identify Monica as Kavya. So as long as the number of these false identifications is kept very, very small,
Yeah.
right? Reasonably small. One odd false identification is all right. Like, you know, fingerprint recognition also is not 100% foolproof, no?
Correct. So that person will complain, and then
Yeah.
you will come to know. And then you
Or identifying people by face or something.
Yeah.
You make mistakes,
Yeah.
right?
Especially in that, yeah. So here it's kind of because we have a very small set and we can easily check if 2 people are the same or different. But yeah, face is very eminently possible, or fingerprint, that based on this somebody could be wrongly classified as the person.
So if I asked you this, you know, we have these cards and we saw that we could use gender, we could use town. Town is too much information, I think. We can say state, something like that. We can say even month also has too much information, but we could just divide it into quarters, or first half and second half. Gender, male and female. Grade A, B, C, D. Say state, something.
Or some district maybe,
District.
because many of these are from the same state, I think. Many are from Tamil Nadu. So
Okay.
I think,
There's no information. Okay,
Yeah.
leave that. We will not use that then.
yeah,
We can say grade for maths or
yeah,
something.
correct.
So suppose I take like this different properties of the student, with minimum, very little information, because to check it must be easy, right? So carrying that information also should be very easy to do. Then what is the minimum number of such variables that I need to check before I can find out the person uniquely? How do I, what, is there a problem there? I mean, sitting there?
Yeah, so you want to make this diagram have
As
as few levels as
few levels as possible.
right. You don't want to ask
As
each
small
time
a
you
tree
go
as
down.
possible.
Yeah, you want as small a tree as
don't want to have too many branches also, right? Otherwise the
Yeah.
tree becomes very big.
Correct.
12
So
branches.
that's why we cut down this 12 into 4.
4. So few branches and lower depth. So if I have 4 branches at each node, 4 or 2. If it is 2, then if it is depth of 3, then it becomes 8, right? 4 means I may get 4 into 4 into 4, I get 64, that's also too many. But I have 4 into 2, 8 into 2, let us say 16. That's okay, something like that.
Yeah.
It can't be 16 because we have more than 16 cards, 30 cards. It has to be at least 32. But you know, can I do it with 32? Let us say. Which variables would I choose
Correct.
in such a way that by checking the variables in sequence, one after the other in a tree form, I can uniquely identify the person.
So when you ask a question like we saw here, it breaks it up into some groups.
It breaks it up into groups, yeah.
So maybe you can look at each question and kind of look at how the groups are. If the groups are getting separated well, then that's a good question. If many people are lying in the same group, then you're not getting much information. From asking that question. So you can ask for
Which
each question which is giving us more information about the separation. And then we ask that question, go to the next step, again ask among all the questions which are remaining. Of course, now we have asked, so when we come here, we know everybody in this has got the same 3 months.
This is what we did actually. We looked at the cards and figured it out.
Yeah.
But you could do it systematically,
Yeah.
presumably, right?
Yeah, you can say what all questions are still available to me. So we can decide on some questions we are allowed to ask. And among those, we say which questions are still remaining, because one question we have already asked.
Yeah.
No point asking it again because everybody is in the same bracket. Same bracket there. But now, if we ignore the birth month, then we can ask whether it's a town is a good question or the grade is a good question, and so on. Right?
So you're saying basically what we do is, but we are doing only for a sample. We're not doing
Only for a sample.
So you take a sample. So you have.
Yeah. So you take a sample, and then on the sample you might ask yourself, right? So if my first question is, if I first start by asking, say, month, then I will get some, say we have these 4 quarters, right? So I will get some 4 groups, right? So I will get some group 1, group 2, group 3 and group 4. So that will give me some split. If it's a good split, it might be equal, but it might be slightly unequal, like you saw here 4 2.
In this case, it became
Right?
4 2 2. Yeah.
Now I can have another 4-way split like grade.
Okay.
Okay.
For the
this
same
will-
sample.
For the same sample, and I will get some different groups
Okay.
of
And
the
you
same
can check-
same cards,
Huh.
right? And then we can ask whether this distribution is better than that distribution.
Want to try that?
Okay, we can try that, right?
I'll take 1, 2, 3, 4, 5, 6 cards is good, or should I take more? 10 I took
No,
last time.
10 is I think better.
Okay. All right. Let's take 10.
Okay.
Okay. Here are 10 cards. Right.
So this time we will just count. We don't know. We don't care how many are. I mean, who they are. We won't write down who they are. We just want to know which is giving us a more even split.
More even split, right?
So
Grades. What is this? This
so
group.
yeah,
This is
yeah. So this is
Jan to. Okay.
yes, yeah. So this is July. So this
July.
is the third group.
Hmm.
So I put a tick here, right? So I put a mark here, like we did in our very
Okay.
first class.
All right.
And no, and we also do
We
it
do
in the
this
grade.
also.
Yeah.
Hmm.
So grade is a D. So this is one person has got a D and was born there. Then
This one.
this is again a D.
D.
Okay, and in May. So in the second group.
Okay.
Okay, August is the third group. Again a D. So I think you've picked up a lot of bottom people in this pie.
This is not working. That's what it
Yeah,
shows.
yeah,
Huh?
yeah. Again a D.
Oh, it's
from
not
Decem-
random.
From December.
Hmm.
209 is a C from March. So now we are getting a better distribution here.
Hmm.
219 is again a C only, I think. Right? I think we had our grades. I think up to 227 was a C. Yeah, 200 to 226 is C. C and October, the last one. Okay.
24.
4 is again a C, and in September, in the last one again. No, the third one.
224 exactly.
24 and in December. Okay. One more. No, this is a B, and in May. And finally, we have a 244, which is still a B, and in July.
So the sample is
Yeah.
chosen. I mean, we didn't choose it correctly,
Yeah.
but regardless,
It says that
Sample
month is
tells
giving
us
a little bit of better distribution. than-
slightly better distribution
yeah.
than this one
Yeah. Because here, for example, one group is not being represented at all.
at all.
Right?
So you should go with this ideally.
Ideally, we would ask based on this
Based
sample.
on this
we say
sample.
that month is a better question to ask than grade. Now we can
First
do the
question.
Yeah, first question.
And then you could do the same thing at the next level.
Yeah. Now I can say, of course, now here the sample is small, but how
You
does
could do it for the whole. Again,
Yeah.
you can pick a sample and do the question from beginning again.
yes,
isn't
you
it?
can- Yeah, you can do that also. But you'll have to pick people who are in this group to ask that question, right?
Ah, is it? Yeah, that's what you should do, right?
Yeah. So you'll have to take all the people who are born between, say, what is this, July and September,
Ah.
and then ask what is the next question for them.
Let's try
So
that.
we can do that.
Let's
so we
try
take out everybody who was born between July and September. Hopefully there are a few.
Okay, this is July,
September, August,
August,
July,
July,
September,
September,
July,
July,
November, February, March, January, February, May, April, September. Ah, I see a September.
yes, September,
May.
November. Okay, we have so many.
Yeah. So now we have all these people who
This is
are
all the
in-
people. This is not a
if we
sample.
had-
This is a
if-
full set
The
actually.
full set, if we had applied month, we would have come down here to these.
All
ones.
of them would have come to
Yeah.
these.
And now we want to
We have to
ask.
see which question should ask.
Hmm.
So the choices are grade
Yeah.
and
So one choice is grade. The other choice is town and city, but that we already decided is too specific.
Yeah.
So well, we have gender, of course, which is only a two-way split.
two-way split will clash. Anyway, it will clash.
Yeah. Yeah. So we can see. I mean,
We'll try gender. Gender might split it into two equal groups, so it may
Yeah.
actually be good.
yeah. So we want to know whether it's going to be an unequal split or an equal split. That's
Yeah.
what you want to know, right?
Yeah.
So Okay. So now the grade 252 is a, let's put the grade things out. So 252 is a B, I think. This is our grades. So 252 is a B. So I have a person who's got a B and who's a male, right? So let me write MF. This is D, C, B, and A. Okay. And
227.
227 is also a B, and is also a male. 240 is also a B, but is female. 181 is a D and is female. 196 is a D and is male. 224 is a C and is female. And finally 244 is a B and is female.
So it looks like gender is good.
So gender gives us a
equal split,
and this is again giving us a more unequal split.
So this way we can do. So the idea basically would be to try and pick, if you are going to ask a question, you want to ask that question which will distribute for the answers. If you have 3 answers, multiple choice, like 4 choices.
Correct. It will try to make them into
equal buckets. It will distribute them equally.
Yeah. So that could be one strategy that we follow.
So whichever out of the questions, which one tries to distribute the most
evenly would be the best question.
Best question to ask at that stage. Then you keep asking questions, and hopefully you ask as few questions as is required you need to ask, and you end up with the answer. So this would be a bottom up algorithm.
Yeah, because we are deriving this. So this tree, finally when we draw the actual tree like we did there, we have essentially a program, right? We have some kind of procedure which tells us how to classify a student, and we got that procedure by looking at the data. We didn't decide in advance that we should ask grade first or we should ask month first, right? So in that way it's not something that we analyzed and said this looks like a better one. That it was, if the sample is different, we'll get a different answer. So if the data changes, then this tree will look different. So we have a strategy to build a tree.
We don't have a,
but the tree itself comes from the data.
The
so we know that finally we are going to get something that looks like this. But what are the exact questions that we ask at each stage? Those are determined by the data. So that part is bottom up.
So they say learning and all. This is learning. This is the learning algorithm.
Yeah. So this is
how it works.
This is more or less how it works, right? So we have a broad idea that we are going to be able to discriminate these students based on asking few questions about the data that's on the card. Now, which questions to ask is learnt from which are the minimal questions. So you think about a doctor, no? A doctor is doing the same thing, right? So there will be, you will come and you will have a lot of symptoms, you know, you will say my head hurts, my stomach is paining, I have a headache, my right shoulder is stiff. And then you will take a test and you will come with some blood test report, with some other test report and all that. So there's a whole mess of data there, right? Both the patient is saying plus what the patient's reports are saying. But the doctor has to be smart enough to understand that these 4 things together identify some disease or some condition, right? And the rest is all just some, maybe this person is generally, you know, suffering from some stomach problem.
He may also have got a sprain or he may have fallen down sometime.
Correct. So all these things are not relevant to this.
They are not relevant to this particular.
So that goal of, so there again the doctor is using a kind of, so there the data.
Ask some questions also.
Yeah, ask some questions, but for the doctor this data is coming from the medical experience that the doctor has. The doctor has seen so many patients, has learned.
College, they learned.
Yeah, so they learned so many cases in college.
They know that person with fever, these are the possible diseases. So these may be some additional symptoms. Look for them.
Yeah. So really we are doing a kind of diagnosis.
Oh, this is like
So this is like diagnosis, right? So we are trying to say, but the question is that, like an
which
expert doctor, which questions to ask, right? So a bad doctor will just say go and take 100 tests and come back. Whereas a good doctor will try to identify which are the relevant tests. You know, I want to rule out this, so you take this test, or I want to confirm this, so you take this test. So the doctor will not